Hi everyone. I thought it was time to do an update on the Swiss landslide situation going on right now. In fact, the town's been evacuated yet again, but this time I'm including the results of InSAR satellite data analysis that was provided by ValueSpace. So again, I want to send a shout out to ValueSpace. I really appreciate their ongoing support to really enhance the value of these videos and bring what I think is a very unique perspective, independent perspective to what's going on in these types of situations, whether it's for infrastructure or geologic situations that threaten cities and other infrastructure. So as a reminder, this is the area of the Swiss Alps called Brienz-Brinzauls. And this whole village now has been evacuated again in November 2024. It was previously evacuated in the summer of 2023. So you can see there's numerous cracks throughout this old town, this village, several hundred years old. The steeple of the church is tilted. So there's really broad movement across the whole town, in addition to all the debris that's sliding down from the top of the slope. I mean, look at these massive chunks just blowing down the hill. So it's an ongoing situation, quite dangerous. So as a reminder, here's a brief description of how this InSAR data is collected, and if you need more information, you can check out the ValueSpace link in the description to this video. So ValueSpace works with the Sentinel-1 and 2 data collected by the European Space Agency. This is satellite-based radar that scans the surface of the Earth, and a given point on the Earth has a repeat pass every 12 days. So by analyzing the changes in surface elevation between passes, you could determine if there's likely to be areas of movement or concern for a variety of infrastructure projects or geological features, that sort of thing. So there was an extensive subsurface investigation to support the geotechnical engineering analysis of what was going on with this slide situation. This was conducted in 2019. They had to use heavy-duty cargo helicopters to transport the drill rig and associated equipment up to the mountain slopes. They got it all set up here. Very challenging work conditions. So they're using a triple barrel coring system. You can see they're screwing the casing together, advancing the drill bit, and they retrieve the core using wire lines, so it's very efficient. Looks like a dolomite rock core here, a large diameter, looks like about 4-inch diameter core. And they use those holes to also install instrumentation such as inclinometers and piezometers, much as they've done at the Rancho Palos Verdes landslide situation in California. Now I came across this really good paper that describes the technical aspects of this landslide. I've got a link to this article in the description if you want to check it out. So you can see this is a plan view of the overall sliding mass of debris. And this is what it looks like in cross-section. It's a rather deep-seated shear surface, and it involves not only the whole face of the mountain slope, but the entirety of the town below. So you can see that explains why the town is moving with all the distress, with cracked buildings and tilted structures. And then they also have the threat of actual material sliding down the slope and engulfing them in the town below. So no wonder it's been evacuated. Just a close-up view of this slide surface. You can see we've got dolomite, which we saw in the core sample, overlying schist, which is a metamorphosed shale. Now let's get into the InSAR data. So we've got areas in the town as well as on the mountain face that we're going to look at. So the ValueSpace analyst identified very clearly very high zones of relative slope movement throughout the village. So we'll just get another view of what this inset area looks like. Once you have all your data points, you can create these polygons and get a plot of what the movement looks like within each polygon. So it shows independently what everyone already knew, is that there's a lot of slope movement throughout the town. But again, I think it's very interesting to see this data on an independent basis. Now let's look at a few points on the mountain face, this debris slope. So we got these red points. I sketched out this area here, and this is what the plot looks like, showing significant downslope movement, which we would have expected based on the reports. Now the other benefit of this ValueSpace data is that it includes a suite of satellite photos. And the ValueSpace analyst pointed out this area, which I thought was very interesting. So we're zooming in here, and what we're going to see here is look at the scarring on the pasture here as these massive rock boulders were skipping down the hill, gouging out soil and grass cover as it bounced along, narrowly missing this house. I mean, this boulder is very large. It looks like it's probably 15, 20 feet in diameter. So whoever was in that house was extremely lucky that they didn't get hit by that boulder. The other interesting thing about this paper was a risk assessment decision tree. And it's a very rational approach to figure out what is going on with your sliding situation. So it starts out with, is the acceleration observed for more than 6 months? Does the failure volume involve material in excess of 250,000 cubic meters? And in this case, it's about 1.2 million cubic meters of rock debris that's sliding down the hill, which is over 1.5 million cubic yards of material. And then it goes through different scenarios here to determine what action should be taken. So you have preliminary community warning, village evacuation, entry ban, and then closure of distant traffic lanes. So the townspeople seem to be taking this all in stride. I mean, obviously it's massively disruptive, but they're living under the threat of significant geological hazard here. And contrast that with what's going on in Rancho Palos Verdes with the ongoing efforts to de-water the landslide mass. And they've tolerated movements of the slope and numerous foundation repairs for these houses over the decades. But that movement was associated with a relatively shallow slide surface of less than 100 feet. And then in the last year, they've discovered that there's a much deeper slide surface at a depth of around 330 feet. So a massive area that all these homes are just along for the ride, much as we see here with this Swiss village. So with that, I want to send out a shout out to the channel members. I really appreciate your ongoing support, as well as those of you who've provided super thanks. That's another great way to support the channel. I'm going to roll credits at the end. As I've done with several of my recent videos, I've got a couple of book recommendations if you want to check it out. You know, Samuel Adams doesn't get the credit he rightly deserves, in my opinion, for his successful role in supporting the American Revolution. And this book here is by Stacy Schiff. I really enjoyed this book. You know, Sam Adams really wanted to be behind the scenes, and he was successful in that, but I think it's high time that more people appreciate what he actually accomplished, which was a lot in supporting the American Revolution. And then about the same time, within a couple of weeks, I came across this book about Benjamin Franklin's role in supporting the American Revolution as an ambassador to France for the United States. And I didn't notice until I was doing this video that it was the same author. I was wondering why there was so much interlaying of the storylines, and it makes sense now. So I would suggest, if you want to check out these books, that you maybe get both of them and read them together. But if you were to get just one of them, I'd probably get the Sam Adams book, because I think Franklin's much better known to people than Sam Adams. So if you want to check these books out, there's a link in the description. Also, as a reminder, I just set up Buy Me a Coffee. That's another great way to support the channel if you'd like to consider it. There's a link for that in the description.